All right, guys, we are doing 3.2, which is the sum and difference formulas. This goes back to you have to know your unit circle well. So first, go ahead and jot down this sine of 90 equals sine of 30 plus sine of 60. There's a question mark there because I want to know, like, what do you think? Is that actually true?
Just don't do this.
All right, so let's think about, well, first, what do you think? Is this true? Do you think we can just add two angles together and that'll give us the sine of two angles is the sine of another angle? Maybe. Let's look. What is the sine of 90 degrees? 1. Okay. And then we're not sure. Does that equal, what is the sine of 30 degrees? Here, do we forget our circle? It is 1/2. And then the sine of 60 is root 3 over 2. They're not both a half, okay? So what do you think? Is a half plus root 3 over 2 the same as 1? No, definitely not true. So that's why we have these sum and difference formulas, so that we can actually find the measure of some angles that are not on our unit circle using values that we already know. That's me assuming that you still know your unit circle, okay? If you forgot it, you should review. Maybe. All right. So here we go. We got some formulas. I'm gonna give you some
boy.
Welcome back, guys. Here we go. They're not as scary as they look because you'll start to see patterns. But we basically have, for cosine, we have adding two angles and subtracting two angles. Sine, adding two angles, subtracting. Yes, you will need to know all of these, tangent, adding, and subtracting. You should start to see some patterns with these as you write them. So guys, write them all down and then take a minute to think about them. I know when you're copying, sometimes you aren't actually thinking. So guys, looking at the two cosine formulas, what do you notice? They're the same formula except different signs. Okay? And does it match or not? Okay, so cosine, when it's an addition formula, you know you've got a subtraction over here. Subtracting two angles, you know you'll have an addition over here. And then if you look at the sine formulas, again, they're the same two formulas, but this time their signs match. Okay? The tangent ones, if you look, the numerator is going to match your sine, denominator will be opposite. So numerator matches, denominator's opposite. Okay? I know this looks like a lot. You're going to use these enough that there shouldn't be a ton of like, okay, I just have to sit down and memorize these formulas. Like you're going to do enough practice problems with them that you'll use them over and over, and that should help you learn them. Okay? So let's try them. All right, guys, so your first one here. Go ahead and jot it down. We're going to find the cosine of 15 degrees. Just jot the problem down real quick, and then I'll walk you through this one. All right, everyone agrees 15 degrees is not something on our circle, right? But are there two angles you could add or subtract and you would get 15 out of them? What did you say? 45 and 30. Let's try that. I'm going to do cosine of 45 degrees minus 30 degrees. All right, from here it is just using that formula. So look up above at the formula you wrote down for cosine of something minus something. It's cosine of both, right? Then plus sine of both. So we're going to write cosine 45, cosine 30, plus sine of 45, sine of 30. Does that make sense how I'm using the formula? Then we get to evaluate it, because these are now things that we know from our circle. So what is the cosine of 45 degrees? Root 2 over 2. Times, what is the cosine of 30 degrees? All right, plus sine of 45 degrees. Root 2 over 2. You're on a roll, Ryan. Finish it out for me. What's the sine of 30? Okay. We're almost done. Now we just have to actually multiply and simplify. So what is root 2 times root 3? Root 6 over, what's 2 times 2? 4. Plus, what's root 2 times 1? Okay, not a tricky question this morning. What's root 2 times 1? Root 2? Over 2 times 2? 4. Good job. All right, they already have the same denominator, so your last step, you can just write root 6 plus root 2 all over 4. And you're done. You guys see why knowing that circle matters? Yeah. Okay. Questions on the first one? Does this seem easier than proofs? Yeah, just follow a formula. Okay, let's look at our next one. All right, I want you guys to try this one. Sine of 165 degrees. There are a lot of different angles you could add or subtract and get 165. Remember, you have to pick things you actually know from your circle. So don't tell me 150 plus 15. 15 isn't actually something you know from your circle. Well, you did the cosine of that, but I would not recommend using 15. So try this one. Let's see where you are. Yeah, if you need to reference your circle just to think about what those angles actually are, that is fine. And you might pick two completely different angles than the person sitting next to you. That's fine. You should still get the same answer in the end, okay? You guys can talk to each other. Add things, you can subtract things, whatever you want to do. Give you guys another minute, then I'll start going through it up here. Talk to each other, see if you get the same answer, even though you maybe picked different angles. Look like you're ready. Look like you're ready for me. Round two. Yesterday was such a good, like, cold, rainy.
It was
going to
nice.
fall asleep
Yeah.
today. Yeah.
I like woke up, went downstairs to breakfast. It's great. It's probably all the last an hour. I went back upstairs, came back down to eat lunch. It's still great. Went downstairs 3 hours later. Oh, it's still great.
I had to pick up my son early from daycare yesterday, and he was completely passed out asleep. Like, everyone else was up doing something. He's so tired. He's just like sleeping in the corner out to the world. Just like, it's a good napping kind of day. All right, guys, are we ready? All right, I saw some of you pick 120 plus 45. That's great. I saw some 135 plus 30s. That works too. Anybody pick anything else? What we got one second. I'm gonna do 120 plus 45. Okay, so then the formula of this, I would have sine of 120 times cosine of 45 plus cosine 120 sine of 45. Are you guys doing okay with like putting it into the formula? That's not bad, right? Just follow the order that you wrote it in. Then it comes down to knowing your circle. So what is the sine of 120 degrees? Root 3 over 2. And again, if you pick different angles, that's fine. The answer at the end is going to be the same. Okay? Cosine of 45 degrees. 2 over 2. Cosine of 120 degrees. And sine of 45. Okay? So I'm going to get root 6 over 4. And then this is really just minus root 2 over 4. So root 6 minus, wow, that's supposed to say root 2 all over 4. Or if you had negative root 2 plus root 6, either of those are great. How do we do? Yes? Do you notice that it's the same numbers that we had in the first answer? Okay? All of these, when you're doing sine and cosine, you will have a root 6, you'll have a root 2, and you'll have an over 4. The pluses and minuses will be different, but if you finish a problem and you've got like root 3 plus root 5 over 6, okay, something went very wrong, go try again. There's always going to be a root 2, a root 4, or I'm sorry, root 6, and an over 4. Okay? Does that make sense? Let's try another one. Anybody have questions? Anything that went wrong on there? Alright, so different directions here. Now it says condense, and I give you this big expanded formula. So jot it down and I'll show you what we're doing. These are actually the easiest ones on this section. What we're doing in this problem is you have to recognize which formula this is. So I've got cosine 85, cosine 25, plus sine 85, sine of 25. So look at your formulas. Which one is a cosine cosine plus a sine sine? Cosine and then minusing the two angles, right? Okay. So what that means is this is really the same as cosine of 85 degrees minus 25 degrees. And what is 85 minus 25? 60. And do you know the cosine of 60? Aha, yeah. That's it. Okay, so it's just a matter of recognizing the formula and then working in the opposite direction. If you had gotten to this point and it was something you couldn't, like that you don't actually know the value of, then you would just stop there, okay? It doesn't mean you did it wrong because this doesn't simplify, so. Well, then that's a different problem. Then I have concerns about you. Okay. Am I on 4? I'm changing this.
Yeah.
Let's make it cosine of pi over 12. Let's make it 7 pi over 12, just for fun. Does that sound like fun?
Right. Yeah.
Do we have different definitions of fun?
Okay.
We're going to do this one together, okay? So this is giving the angle to you in radians. Yes, you could convert it to degrees, but I don't want you to do that. I want you to learn how to think with fractions, okay? So I'm going to just draw a little bit of my circle here. Pi over 6, pi over 4, pi over 3, pi over 2. I could keep going, right? 2 pi over 3, 3 pi over 4, 5 pi over 6, and pi. Stop there. We know those, right? Yes. Okay. What I'm looking for here is two angles that either I add or subtract, and I get 7 pi over 12. Well, none of these are over 12, so that makes it a little tricky. Could I make all of them over 12? Like, wouldn't that be a common denominator here between all of these? Okay. So what would pi over 6 become if I wanted it to be something over 12?
Pi over 12.
Okay. What's pi over 4 going to be? What's pi over 3 going to be? Do I need to keep going?
Yes.
I can do another one. If I'm trying to get to 7 pi over 12, do I have 2 that I could add together? Yeah. I could do, right, this guy plus this guy. But I'm going to write them as the simplified versions just because I think that's easier for your head. Pi over 4. Like when we go to evaluate it, I think that makes more sense to you. You guys understand what we did there? Yeah? Okay. All right, so then it's just using the formula. So I'm going to have cosine of pi over 4 times cosine of pi over 3. Well, plus or minus, what do you think? Minus sine of pi over 4 times sine of pi over 3. You guys almost know that formula already? Almost. No. Some of you know. All right, so then we evaluate it. What's the cosine of pi over 4? Root 2 over 2. What is the cosine of pi over 3? One over 2 minus, what's the sine of pi over 4? 2 over 2, good. And the sine of pi over 3? 2 over 2. So I've got root 2 over 4 minus 6 over 4. See what I mean? There's those same numbers again. Move it up just a bit. Yep, and it'll be over 4. And the sine doesn't matter. Yep. If it's tangent, it'll be different. But sine and cosine will always have root 2, root 6, and over 4. Yep. So yeah, it's a very good check. You'll know, like, oh, that number doesn't make sense to me. Okay. Because sometimes, guys, a lot of people, you know how to multiply, but sometimes your brain adds, and I say root 2 times root 3, and you tell me root 5. Okay, but that's a good check. You'll know at the end, like, oh, I'm not supposed to have a root 5. I'm supposed to have a root 6. So just use that as a check. Make sure your answers make sense. All right. So this is like a proof, but it's easier because you have the formula to guide you. So go ahead and jot it down, and we'll go through this one. So you're basically doing a proof here. the left side of this, we could expand that with a formula, right? Because this is cosine of something plus something. So I'm going to write cosine of pi over 2 times cosine of theta minus sine of pi over 2 times sine of theta. So again, that is just using the cosine of an angle plus an angle formula. Then from here we can evaluate some things. So what is the cosine of pi over 2? What did you say? Is it 1 or is it 0? It is 0. So I've got 0 times cosine of theta minus, what is the sine of pi over 2? 1 times sine of theta. So 0 times cosine, nothing, right? And then I've got minus 1 times sine, which is the negative sine of theta, which is where I was going. Okay? So a little easier than the other proofs because the formula helps you along the way. Okay, you guys try this one. So we're using the tangent formula, which we haven't used yet. So if you need to look back to that formula, that is completely fine. But use that on the left, and then we'll see how your simplifying goes on the right. Or I'm sorry, on the left as you keep going. See if it matches.
Test to see where there are lots of tissue usage.
This is grabbing two kids like this, it's really fun different teams, and I'm not breaking up into different interview trainings, but it was fun, so I have an interview tests, and I tell interviews, and I love them all, and I just want to use them. So
I just got a fun new. It's got the key stringer in it, but you can take it out.
Yeah. My sister and I were like both really into like different teas, so like for Christmas I already got like an experience with different teas, so
I just got a tea. I have a tea advent chamber. So it's 24 different teas that you get to try every day.
that's really fun.
Yeah,
So,
it's very cute. It's like just little, it's like 2 servings every day.
but it's really just like that she got
They used to get freaky when it's something.
Yes, Matt, we can do it. See you later.
I forgot to do my thank you work.
Okay.
So I'm on page. More like 18 or 30.
Yeah, Charles. See how it was the exact same thing. Are we ready, guys? Okay, so our formula. tangent of pi minus tangent of theta over 1 plus tangent pi tangent theta. Okay. Key here is knowing what tangent of pi is. So what is tangent of pi? I hope it's not undefined because that would be really tricky to use in this formula. So what is it? 0, yeah. So really I've got 0 minus tangent of theta over 1 plus 0 times tangent of theta. So in my numerator, all I have is negative tangent of theta. Denominator, all that's left is 1. So you're there. How do we feel about that one? Okay. No, I know. It's Wednesday. We can do it. No, we can do it. Okay, I think we're on 7. Apparently I can't count today either, so. Go ahead and try this one. A little more going on in it. You're going to use the formula to expand that numerator, and then let's see if you can simplify to turn that side into the right.
Oh. Wait.
It looks scarier than it is, I promise. No, there's some that I know are scary. How are we doing, guys? Start with the formula and then think about how you can simplify. Yeah, we've got just a little more to do, so let's finish up the okay. Guys, while you're working, I see some of you are looking at the calendar back there. We're doing 3-2 today, 3-3 on Friday, quiz next week Tuesday, review for Thursday, and then your test is the Monday before Thanksgiving. It works out nicely. We're finishing the unit right before Thanksgiving break, so that's good for everyone. Did you get it to simplify?
I just realized.
So guys, if any of you know you are gone that Monday of Thanksgiving week, please tell me so you can take your test early. There's nothing worse than coming back after being gone for a week and taking a test. No, don't do it. It's not fun. You've got your review, so you can take it on a review day. Okay, so just let me know. All right, let's look at this one. So I'm going to do the formula for my numerator here. So it's going to be sine of theta, cosine of beta, minus cosine theta, sine of theta, over cosine theta, cosine theta. I know a lot of you got here and then did you feel a little stuck? Okay. At this point, this is where you can break this apart into two fractions. So I can do sine of theta, cosine beta, over cosine theta, cosine beta, minus cosine theta, sine of beta, over cosine theta, cosine beta. All right, do you guys believe me now that it matters that you write the theta and the beta? Like, it's clearly different values, right? Okay. I can get rid of these. And I can get rid of these. So if I have sine of theta over cosine of theta, the angles are the same. So what's sine over cosine? Tangent. That's tangent of theta. And then sine of beta over cosine beta, what's that going to be? Tangent beta, right? And that's exactly where we were going. How many got there? Quite a few. Okay. Questions? Definitely have to know your formula so you know where to start. And on your unit test for this unit, you will have a page that is just you filling in formulas that you'll be graded on. And then you'll turn that in, and then you'll get a formula sheet to use on the rest of the test. So I'll test you on do you know the formulas, but then if you missed one, I don't want you to miss every single question that has to do with that formula. So I'll grade you on do you know the formulas, but then I'll give you a formula sheet to use with the right formulas the rest of the test, just in case you didn't know some. Okay? All right. Am I on number 8? I really okay. All right. This one is different, clearly. You are given sine of alpha equals 3 over 5, and you know alpha is between 0 and pi over 2. Cosine of beta is 5 over 13. Beta is between 0 and pi over 2. And you're going to find the sine of alpha plus beta. So you guys start writing that down. I will explain it. It's another one that looks worse than it is.
We just write straight to like
Yeah, you need all that information. You don't have to write the word given if you don't want to. Makes you feel better to leave that out. That's okay. So it's giving you the sine of A, and then it's telling you what quadrant angle A is in.
Oh, because it's quadrants.
Yes, because we don't know. Without that, you'd have no idea. Well, I mean, you'd narrow down to 2, but you wouldn't really know where they're at. I'm going to make some pictures of this. You guys got to control yourselves this morning. It's been a while. All right, we need pictures with this. So I'm going to draw my alpha picture over here. So everything we know is alpha. this is telling me what quadrant it's in. So what quadrant is from 0 to pi over 2? First one, right? Okay. Remember back to, gosh, I think it was unit 1, when we drew our right triangles. Remember how you always went from the center and then the right angle was to the x-axis? You need to continue doing that, okay? You have to draw it the right way. This is alpha. That's the angle I'm looking at. And I know the sine of alpha is 3 over 5. So what does that tell me about my triangle? Like, where do those numbers go? What now? Okay, positive. And which one is the 3 and which one is the 5? Like, which part of my triangle? Sine's opposite over hypotenuse, right? So 5 is my hypotenuse. And where does the 3 go? Like over here. Yeah, are we okay with that? It's opposite of my angle. What's the other side of my triangle going to be? 4. Okay. That's what you meant, right? If I had to draw it in a different triangle, you guys would have to think about your signs. Like what would be negative and where would those go? Is the hypotenuse ever negative? No. Okay. All right, so we have a little triangle drawn for alpha. Now I'm going to go ahead and draw one for beta. Beta's in the same quadrant, right? So I draw another triangle. Right angle on the x-axis. Beta right in there. And this time I tell you the cosine of beta is 5 over 13. That means I know my adjacent leg and my hypotenuse. So adjacent is 5, hypotenuse is 13. What is that other side? 12. Good. That's a common right triangle. If you don't know it, you can always do the Pythagorean theorem to find that missing side. Okay. All right, we've got everything labeled. So now I'm going to go ahead and do the formula here. Sine of alpha plus beta. That's sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. So we're no longer using things from your circle. You are now finding these values from the two pictures that you drew. So what is the sine of alpha? Okay, here's alpha. What's the sine of it? 3 over 5. Okay, and then cosine of beta. Beta's over there. What's the cosine of it? Okay. Plus. All right, now I need cosine of alpha. Yep. Times the sine of beta. What's the sine in that blue triangle over there? Okay, now we're just multiplying. With fractions, you multiply straight across. So what's 3 times 5? 15 over, what's 5 times 13? And guys, with multiplying like that, if you don't know 5 times 13, that's fine. What's 5 times 10? 50. What's 5 times 3? 15. What's 50 and 15? Okay, that's what 5 times 13 is. Okay. All right, then the other fraction. What's 4 times 12? 48. And again, 5 times 13. 65. Do you guys see how those nicely already have the same denominator? That should always happen. If they don't match, you probably messed up somewhere. Okay, kind of a little check along the way if something didn't go well. And now we are adding. Same denominator, so that's going to stay at 65. And then you're just adding 15 plus 48. What do you get? 60 what? 3. Okay, good. And that is your Not really, because unless your triangle, like if this was an 8, 6, 10, then maybe. But if there's nothing that simplifies within the ratios to begin with, it won't. Okay. Because like here, you could have simplified this, but then you'd have to find a common denominator after that, so it's no point like undoing the work you already did. Okay. I don't think we need another one. All right. We'll stop there for notes.
It's gonna be very good.